Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video I will be solving the paper for exam for February-March 2022. Question 1 says, a ball rolls down a ramp and onto a horizontal surface. The first section of the horizontal surface is smooth. The second section of the horizontal surface is rough. Figure 1.1 shows the speed time graph for the ball. So for a speed time graph, the gradient is equal to the acceleration and the area under the graph is equal to the distance or the displacement. First he says state the time when the ball reaches the start of the rough section of the horizontal surface. So for a horizontal surface, a ball should be moving with constant speed if there is no friction, but with friction it should slow down. So the part where the ball starts slowing down is here. So going down in the graph, we get this part. So we have here every 20 squares makes 1 second. So every 2 squares, that's 0.1 second. So 2.1, that's 2.2 seconds. So this is the answer. Question B says, explain how figure 1.1 shows that there is no resultant force on the ball when it is rolling along the smooth section of the horizontal surface. So no resultant force means no acceleration, which means constant speed. So the line is horizontal at that time, which means that the gradient and acceleration are 0. Question C says, using figure 1.1, determine the acceleration of the ball as it rolls down the ramp. So for acceleration, we get the gradient. So we need to check 2 points. For example, the first point, which is 0 and 0, and the last point here we have on the y-axis, that's 12.8, and on the x-axis we have in the middle between 1 and 2, that's 1.5. So using y2 minus y1 over x2 minus x1, we calculate 12.8 minus 0 over 1.5 minus 0. That gives us an approximated value of 8.5333 recurring, so we can approximate this to 8.53 meters per second squared. Question D says, the ball starts from rest at the top of the ramp. Show that the length of the ramp is 9.6 meters. We can either use the area under the graph or we can use the equations. For a graph, we use the area under the graph. So the first section of the graph is a triangle, so we calculate this area, which is half by base by height, half by 1.5 multiplied by 12.8. So this is what we write. This gives an exact value of 9.6 meters. The next question says, figure 2.1 shows a spring balance used to measure the weight of a baby. The spring inside the balance extends when a mass is suspended from it. The dial shows the extension of spring as a value of mass in kilograms. The spring obeys Hooke's law up to a weight of 175 newtons. Question AI says, state Hooke's law. So it says that the force is proportional to the extension until the limit of proportionality. AI says, state the relationship between the mass of the baby and the force exerted on the spring due to the baby. We can say that the force is equal to the weight, which is equal to the mass multiplied by gravity field strength or gravity acceleration. I says the reading on the spring balance is 8 kilograms. Determine the force exerted on the spring due to the baby. So we use the above mentioned equation. W equals mg. So we multiply the mass 8.0 times 9.8. That gives an approximate value of 78.4 newtons. Question B says the limit of proportionality of the spring is at force 175 newtons. Sketch the extension load graph for the spring. The sketch must continue beyond a force of 175 newtons. So at first, the graph is a straight line through the origin, hence the proportionality. After that, it curves towards the extension axis because it's getting easier to extend. Question C says the baby is carried from the ground floor to the bedroom. The vertical height of the bedroom above the ground is 3.5 meters. Calculate the change in gravitational potential energy of the baby when it is carried from the ground floor to the bedroom. So we calculate the change in gravitational potential energy is equal to mg delta h, or h. So we multiply the mass of the baby, which was 8 kilograms, multiplied by g, 9.8. Or we use the force we calculated before, times the distance 3.5. That gives us a value of 274.4. So we can approximate that to 270 joules, since all the numbers we used are to two significant figures. So we use the same value or the same number of significant figures in the answer. The next question says figure 3.1 and figure 3.2 show how a puddle of water changes on a warm, windy day. Describe the process by which the volume of the water in the puddle decreases. So mainly the examiner wants us to describe evaporation. So we describe it as the most energetic molecules at the surface gain enough energy to overcome intermolecular forces and escape or change into gas. Question B says state and explain one change in the weather that would cause the volume of water in the puddle to decrease more slowly. So we can lower the temperature, and the explanation is that molecules would have less energy. Or we can say slower wind, and the explanation for that would be that there will be more humidity, which decreases the rate of evaporation. Question C says explain in terms of molecules how sweating helps to cool your body on a hot day. So we say water molecules absorb heat energy from skin to evaporate, leaving the molecules of the skin at lower average kinetic energy. That's what decreases the temperature. The next question says a sample of sand has a volume of 0.050 meter cubed. The density of the sand is 1900 kilograms per meter cubed. The specific heat capacity of the sand is 1500 joules per kilogram degree Celsius. Question I says calculate the mass of the sample of the sand. We can use the equation density is equal to mass divided by volume. So mass is equal to density multiplied by volume. So we multiply 1900 times 0.050, which gives a mass of 95 kilograms. Double I says calculate the thermal capacity of the sample of sand. The thermal capacity is equal to the specific heat capacity multiplied by the mass. So we multiply 1500 times 95. That gives a value of 142,500, which we can approximate to 1.4 times 10 to the power of 5 joules per degree Celsius without the mass. Triple I says the initial temperature of the sample of sand is 7 degrees Celsius. The sample of sand is heated using an electrical heater. The power of the heating element is 50 watts. Calculate the time taken to increase the temperature of the sand to 19 degrees Celsius. So the original equation is Q equals mc delta theta, or delta T, and we can replace Q, which is the energy, by power multiplied by time. So power multiplied by time is mc delta theta. So making T the subject of formula, we can divide mc delta theta by the power. So we have the mass, which is 95 kilograms, multiplied by the specific heat capacity, 1500, multiplied by the change in temperature from 7 to 19, that is 12 degrees Celsius, and we divide all that by the power, which was 50. That gives a value of 34,200 seconds, or we can use standard form, which is 3.42 times 10 to the power of 4 seconds. Question B says in some countries the soil is too cold for plants to grow well. In these countries, plants are grown in plastic pots and kept inside. The pots containing soil are placed on sand. The sand is heated using an electrical heater as shown in figure 4.1. Describe in terms of molecules how thermal energy is transferred from the heated sand through the base of the plastic pot. We can say that the hot sand molecules vibrate and collide with the molecules of the pot and then the molecules of the soil, which transfers some of the kinetic energy. Double I says the heating element in figure 4.1 remains switched on. The temperature of the sand remains constant at a value above room temperature. Explain why the temperature of the sand remains constant. So we have the heater switched on, which means there is an input of energy to the soil, but also the temperature of the sand is above room temperature, so there is heat lost to the surroundings. If the temperature remains constant, this means that the energy input from the heater is equal to the energy lost to the surroundings. Or we can say that the rate of heat gained from the heater is equal to the rate of heat loss to the surroundings. So there is no net gain in energy. The next question says a boy looks at the image of a clock in a plane mirror. Figure 5.1 shows the mirror, the clock, and the position of one of the boy's eyes. On figure 5.1, draw a ray of light from the clock reflected to the boy's eye. So at first we can use the distance from the clock to the mirror, and we can say that this distance is the same as from the mirror to the image of the clock. So we would use a ruler to measure that distance and mark the position of the image. And we can draw a straight arrow going from the image to the eye of the boy. But we draw the part behind the mirror as a dashed line to indicate that this is not the real ray of light. The real ray of light came from the clock to the mirror at this point and then was reflected towards the eye of the boy. And we can draw a normal to indicate that this angle is equal to that angle, which are the angle of incidence and angle of reflection. But the normal is also an imaginary line, not a real ray of light. Double I says on figure 5.1, mark with an X the position of the image of the clock. So this is the image. State whether the image formed by the mirror is virtual or real and explain your answer. So the image in a plane mirror is always virtual because it is made of extensions of rays of light, not of the real rays of light. IV says figure 5.2 shows the image of the clock seen by the boy. The boy now looks directly at the clock. On figure 5.3, draw what the boy sees. So an image in a plane mirror would be laterally inverted, which means whatever is on the right is now on the left. So our arm is pointing to the left, but it is upright, so the minute's arm is still pointing upwards. Question BI says the clock is illuminated by a source of monochromatic green light. State the meaning of monochromatic. This means a light made of one frequency or one wavelength. Double I says the green light has a wavelength of 5.6 times 10 to the power negative 7 meters. Calculate the frequency of this green light. So we can use the equation that the speed of a wave is equal to the wavelength multiplied by the frequency. But for light, we should know that the speed of light is 3 times 10 to the power of 8 meters per second. So 3 times 10 to the power of 8 meters per second is equal to 5.6 times 10 to the power of negative 7 multiplied by the frequency. We move this to the other side by division, and we get a frequency of 5.35714 times 10 to the power of 14, and we can approximate that to two significant figures according to the number of significant figures in the question. So we have 2. That makes an answer of 5.4 times 10 to the power of 14 hertz, which is the unit of frequency. The next question says figure 6.1 shows two bar magnets. On figure 6.1, sketch the pattern and the direction of the magnetic field lines between the bar magnets. So between two bar magnets, we have a uniform magnetic field pointing from north to south. So we draw parallel equally spaced arrows pointing from north to south. Question B says figure 6.2 shows the same bar magnets with a coil of wire between them. Name the parts labeled A. These on a generator are called slip rings. Double I says the coil of wire is rotated in the direction shown in figure 6.2. On figure 6.2, draw an arrow to show the direction of the current in the coil and explain your answer. So we use the right hand rule on either side of the wire, so we can pick the left wire. Here we have the magnetic field pointing to the right, so we use the index finger pointing to the right, and this part of the wire would be moving upwards according to this arrow, so the motion is upwards, and the middle finger is pointing into the page, so the current would be into the page. So we draw this arrow like this, or on either side pointing into the page on the left or out of the page on the right. The required was only one arrow, and we explain what we just did. Index finger to the right, thumb upwards, middle finger into page. Triple I says explain how rotating the coil in figure 6.2 continuously causes the galvanometer needle to show an alternating current. We can say that as the coil moves, it cuts the magnetic field of the magnets and induces voltage or EMF. So basically we start by explaining electromagnetic induction, and then we explain why it is an alternating current. So as the angle of motion changes while rotating, the rate of cutting and voltage changes. Also, each side of the wire reverses direction of motion, so current is reversed. So basically in an alternating current, the current changes direction and changes magnitude. The rate of cutting controls the magnitude, and the direction of motion controls the direction of the current. The next question says figure 7.1 shows a circuit including a 12-volt battery and two identical lamps. The 12-volt battery consists of cells connected in series. Each cell in the battery has an EMF of 1.5 volts. Determine how many cells are in the battery. So the EMF should be equal to the number of cells multiplied by the EMF of each cell. So we have the total is 12 and the number is required, and the voltage of each cell is 1.5. So we divide 12 by 1.5, we get 8 cells. Question B, I says when the switch is closed, the ammeter reading is 2.4 amperes. Calculate the total resistance of the circuit. So for the total resistance, we get the total voltage divided by the total current, which is 12 divided by 2.4. That gives an answer of 5 ohms or 5.0 ohms using the same number of significant figures. BII says each lamp has a resistance of 3 ohms. Calculate the resistance of Q. So here we have Q in series with the lamps, and the lamps are connected in parallel. So we can calculate first the resistance of the two lamps in parallel using the product over sum equation. So we multiply 3 by 3 over 3 plus 3. That gives an answer of 1.5 ohms. Then we use the series equation, which gives the total resistance is equal to the resistance of the lamps plus the resistance of Q. So we have 5 equals to 1.5 plus the resistance of Q. So we subtract 1.5 from 5. That gives an answer of 3.5 ohms. CI says on figure 7.1, draw the symbol for a voltmeter that measures the potential difference across the two lamps. So we can either connect the voltmeter from the outside part of the lamps, or we can connect it to one of the lamps or the other. or in between them. These are all parallel connections and will all give the same reading, so either one is correct. CII says calculate the power supply to one lamp. We have three equations for power, either VI or V squared over R or I squared R. The easiest one would be this one, since we have the current in the circuit and those are identical lamps. So if we have 2.4 amperes going into the branching and the lamps are identical, each branch gets 1.2 amperes, which is half the current. So we know the current of the lamp and we know the resistance of the lamp, which is 3 ohms. So we can calculate power equals I squared R. Then we substitute 1.2 squared multiplied by 3. That gives a value of 4.32 watt. The next question says a radio is connected to the main supply using a step-down transformer. Draw a label diagram of the structure of a basic step-down transformer. So first we have a square or rectangular core. Then we draw the primary and secondary coils. The primary coil is connected to an AC supply. So we draw the coil like this, or just a spiral. Then reconnect to the power supply and label this primary coil. This part is the iron core. And since this is a step-down transformer, we should have less turns of coil on the secondary side, and we leave it open to a connection. Then we label this secondary coil. Question B says explain the operation of a basic transformer. So we have 3 marks here. That's the basic 3 sentences. The AC in the primary coil creates a changing magnetic field, and the iron core increases the strength of the field or transmits the field to the secondary coil. This causes a change in flux. So we say the change in flux or the cutting of the field at the secondary coil induces an EMF or a voltage. If we have more marks, we would say that as a number of turns on the secondary coil increases, the voltage on the secondary coil increases, or vice versa. C says the voltage of the main supply is 230 volts. The output voltage of the transformer is 6 volts. Calculate the value of the turns ratio NS over NP, which is secondary to primary. Give your answer to 2 significant figures. So NS over NP is equal to VS over VP, since they are proportional, which is equal to 6 divided by 230, which is approximately equal to 0.026 or 3 over 15. This question is about logic gates, so you can skip it for the new syllabus. It says figure 9.1 shows a digital circuit. Explain what is meant by digital. It means a signal that has discrete values, or for binary digital only has 2 values, high and low, or 1 and 0. II says table 9.1 is a truth table for the digital circuit shown in figure 9.1. Complete the columns C and D in table 9.1. So for C, that's the output of an AND gate. So an AND gate would only give an output 1 if both inputs are 1. So the rest is 0. And for D, it's the output of a NOT gate from the input of C. So it reverses the input. So 0 would be 1 and 1 would become 0. State the single logic gate that would produce the same output D from the inputs A and B. So basically we reverse the input. So basically we reverse the output of an AND gate. That would be an AND gate. Next question says the isotope americium-241 is represented by Am-241 and 95. This isotope decays by an alpha emission to an isotope of neptunium. complete the nuclide equation for this decay, we should memorize the numbers for an alpha particle, which is 4 at the top and 2 at the bottom, because it's 2 protons and 2 neutrons. For the neptunium, we should balance the number at the top with the 2 numbers on the right hand. So we subtract 241 minus 4 and we get 237 at the top. Then we subtract 2 from the bottom, which gives 93. Question B says, figure 10.1 shows a simple diagram of a smoke detector. The smoke detector contains a small sample of americium-241. This isotope ionizes the air between the metal plates in the detector. Question I says, describe how the americium-241 ionizes the air. First, we say that the alpha particles are positively charged. So as they move through the air molecules, they attract electrons from the atoms, forming positive ions, since atoms losing an electron creates a positive ion. Double I says, suggest and explain 2 reasons why smoke detectors use an isotope that emits alpha particles rather than an isotope that emits gamma radiation. The first reason is that alpha has a higher ionizing power, so it will create larger charge and current for the sensor. That's one. Another thing is that alpha has a short range in air, so it will not go far in the room beyond the sensor, which is less harmful. This was the end of the exam. I hope you enjoyed this video and found it useful to you, and I will see you in another video.